Dear students, welcome to HomeLearns classes. In this class, I will solve for you the exercise 2.3 of chapter 2, Relations and Functions. Let's come to question number 1 of exercise 2.3. Which of the following relations are functions? Give reasons. If it is a function, determine its domain and range. What you have to find out in these part 1, 2, and 3 part, that first of all you have to tell if it is a function. If it is a function, then why it is a function, then determine its domain and range. So this is given 2, 1, 5, 1, 8, 1, 11, 1, 14, 1, 17, 1. These are the elements x, y, x, y, x, y, x, y, x, y, x, y. Okay. Since 2, 5, 8, 11, 14, 17 are the elements of the domain of given relation, and these elements have unique images, hence it is a function. Each element has unique image. Each element has unique image. Let's see with the help of graphical representation. 2, 5, 8, 11, 17. 1, 1, 1, 1, 1. 2 has only one image. This is the x, this is the y. 5 has also only one image. 8 has also only one image, that is 1. 11 has also one image. 17 has also one image. This relation is a function, and the domain of this relation is 2, 5, 8, 11, 14, and 17. This is the domain. And range. What is the range? Range is the image, that is the 1. 1, 1, 1, 1, 1. So it means range is 1 only. Now in the second question, 2, 1, 4, 2, 6, 3, 8, 4, 10, 5, 12, 6, 14, 6. Is this relation a function? Yes. Again, this relation is a function because its domain has an only one and one image, unique image. 2, 1, 4, 4 as 2, 6, 3, 8, 4, 10, 5, 12, 6, 14, 7. It is a function for the same reason as given in question number 1. And the domain of this domain is 2, 4, 6, 8, 10, 12, 14. And range is 1, 2, 3, 4, 5, 6, 7. This is the range. 1, 3, 1, 5, 2, 4. It is not a function. This relation is not a function. Why? Because there are two different images corresponds to domain. 1, 1, 2, x, y, 3, 5, 5. This 1 has a this 1, 2 has 5. So this is the duplicacy here, means no unique images. That's all about question number 1. Now come to the question number 2. Question number 2 states find the range and domain of the following real numbers. Okay. Let's make the figure again. One, 2, 3, 5. One has 2 images. 2 has only 5 images. That's all about. Hence, this is not a function. Now come to the second question. Find the domain and range of the following real functions. If fx is minus x, so this is a modulus function. If fx is, the function is like this. There is a typo error. This function is like this. fx is such that x belongs to a real number, because these are the real functions. We know that modulus function is equal to x if x is greater than 0 and minus x if x is less than 0. Therefore, fx is minus x equal to minus x if x is greater than 0, because that is the reverse, and x if x is less than 0. Because the minus sign is out of the functions. Minus x plus minus x, then it is a minus or it is a plus. Reverse of this. So f is defined for x. The domain of f is equal to R. It can be observed that the domain range for this function is fx is equal to minus x, all real numbers except positive real numbers, or we can say f is equal to this, and the domain of f is equal to all real numbers. So range is the all real number except positive real numbers. And second is fx. Fx is, question is like this. There is a typo error. 9 minus x square. 9 minus x square is defined for all real numbers that are greater than or equal to minus 3. It means if x is minus 3, then it is 9 and it will be 0. So greater than or equal to minus 3 and greater than or equal to minus 3 and less than or equal to 3. We can show it fx is such that x is such that x is greater than equal to 0 or less than equal to 3, or it lies 0 to 3. And for the another case, x is such that minus 3 less than equal to or greater than equal to, or its the range is this minus 3, 3. So that's all about the solution for this. Range is 0, 3. Domain is minus 3, 3. This is the domain, this is the range. Question number 3. A function is defined by f(x2 minus 5). Write down the values of. If f is 0, then it is 2 into 0 minus 5, and this becomes minus 5. F is 7, then it is 2 into 7 minus 5, 14 minus 5, and it becomes 9. Fx is equal to minus 3, then it is 2 into minus 3 minus 5 means minus 11. That's all about it. It's very simple. You can put values of x only in x. Question number 4. The function t, which maps temperature in degree Celsius. Temperature in degree Celsius into temperature in degree Fahrenheit, or 9C divided by 5 plus 32. C is for the centigrade. You have to find if T is 0. Question number T is 0. TC means T is 0. It means T0 means C is 0. 9 into 0 divided by 5 plus 32, 0, 0, 32. If T temperature 28 degrees Celsius means C is 28, then 9 into 28 divided by 5 plus 32, 9 into 28 is equal to 252 divided by 5 plus 32, and 252 plus 160 divided by 5, and it comes out to be 412 by 5 and 82.4. And again for T is minus 10. If C is minus 10, then 9 into minus 10 divided by 5 plus 32 to minus 18 plus 32, and it comes out to be 14. And if TC is equal to 212, TC is equal to, here TC is 9C by 5 plus 32, it is equal to 212 in fourth case. You can solve it. 212 minus 32 is equal to 180. 9c is equal to 180 into 5. C is 180 into 5 divided by 9. 20. That's 100. The value of t is 100. Now the last questions of the exercise 2.3. Find the range of each of the following functions. Here the function given 2x is 2 minus 3x. X belongs to R. X is greater than 0. It means it's a real number that is greater than 0. So how the value of fx can be written, or how to range can be find out. If x is x, let's x is greater than 0, let it consider for x and fx. For values, if x is 1, if x is 1, then it comes out to be minus 1. If x is 2, it comes out to be minus 4. If x is 3, it comes out to be minus 7, and so on. All the real numbers you can calculate for fractions also. What is the range of this? Clearly observe that range of f is the set of all real numbers. Is the set of all real numbers less than 2. Minus, you have to subtract less than 2. You can define it as a minus infinite 2. Minus infinite 2. Now for the real numbers, again with the help of the example, or I will solve for you by the alternate values. Let x is a real number. That is, it is the square, x square plus 2a, x square plus 2, x square plus 2. Then x square is greater than equal to 0. If x square is greater than equal to 0, then x square plus 2 is greater than 0 plus 2. X square is greater than x square plus 2 is greater than equal to 2. What is x square? X square is fx. Fx is greater than equal to 2. So the range is that 2 to infinite. You can solve it for other also, for other questions. Similarly, you can do it for above question number 1 also. You can use this method also. If x is a real number, it is clear that range of all the set of all real numbers is a real numbers, and the range for it is equal to real numbers. That's all about solutions for exercise 3.2. Now the remaining portion is miscellaneous exercise. The miscellaneous exercise will cover full chapter 2. Then in the next class, we will revise the complete chapters by solving miscellaneous exercise. Please keep watching HomeLearns. Thank you.